Hello, and welcome to a tutorial on a special area of application for our safety controllers. My name is Volker Marx from Kendrion, and this tutorial is aimed at anyone who needs a safety solution without using a CODESYS PLC. The classic use of our safety PLC, now available in 3 variants, is under CODESYS. However, there are many inquiries from the AGV and robotics sectors, where proprietary hardware and software is often used and which still want to use our safety PLC. So let's first look at the 2 minimum requirements for using our safety controllers. Point 1. An EtherCAT master is absolutely essential. Our safety PLC transmits its safety-relevant data, the yellow data, via a so-called black channel. This is embedded in the EtherCAT frame and ensures safe communication between the safety PLC and the safety slaves. The gray data, that means the non-safe data of other EtherCAT devices, and the yellow data are distributed in the frame depending on the EtherCAT configuration. Point 2. The programming of the safety PLC is always done with CODESYS. CODESYS is a manufacturer-independent software platform used in automation technology for programming industrial controllers. CODESYS is free of charge and can be downloaded from the manufacturer's website. We use it only as a safety editor and therefore do not need any special PLC experience. What exactly is the task of the EtherCAT master in safety communication? EtherCAT communication is based on a cyclical process image that consists of reading input data and setting output data. The EtherCAT master knows the position of the gray data in the frame due to its configuration. The safety data, on the other hand, is managed by CODESYS and is therefore not known to an external master. What is the solution? Well, the EtherCAT master needs a complete description of the process image. This enables it to copy the safe input data to the correct positions of the safe output data. But where does this description come from? To clarify this question, practice is of course better suited than gray, or in this case, yellow theory. Step 1. Creating a safety program in CODESYS. As this would go beyond the scope of the tutorial, you will find a link to detailed instructions below the video. I therefore assume that you have installed CODESYS and have also successfully created your safety program. In this tutorial, we use a safety PLC EC with integrated bus coupler, a safety I/O with 16 inputs and 4 outputs, and a safety I/O with 8 inputs and 2 outputs. Let's move on to the key points of the CODESYS project. We use ControlWin V3 as the controller. This is a software PLC that is available after the installation of CODESYS. Then, under the safety PLC, you will find the safety application, and there also the blocks with the safety program. Here's a simple example with the monitoring of the 2 safety I/Os and a 2-hand block from the CODESYS library. We also find the exchange variables for communication with the gray application here. Here we have a variable of type word which shows us the status of the 2-hand block. Of course, this variable also exists in the gray world. Step 2. Export of the ANY file. As the export option is deactivated by default in CODESYS, it must first be activated.
Tools, then Customize.
Click anywhere in the File menu and select Add command. Add the Generate EtherCAT XML command under Devices. After confirming with OK, the command appears in the context menu of the EtherCAT master. Right-click on the EtherCAT master and select Generate EtherCAT XML. Save ENI file in XML format. If you use exchange variables and want to easily determine their position in the frame, you should export them. Project Export and then tick only the exchange variables. By default, you will find them under Logical GVL. Step 3. Determining the position of the safety data in the EtherCAT frame. To simplify this step, Kendrion provides the tool Kendrion ENI Studio. The exported ENI file can be loaded here, and we see the input process image on the left and the output process image on the right. To also determine our exchange variables, we load the CODESYS export file and we now see the variables marked in green and with their CODESYS name. If we click on Info ANI file, we will find the exact positions of the secure data and also their copy instructions. But first, our exchange variable. This is located in the cyclic input frame at position 14 and 15. The yellow and gray variables are distributed in the frame depending on the configuration, and fill bytes can also be inserted to ensure the correct alignment. The exact copying instructions for a third-party master can be found in the copy information table. There are 4 instructions here. Line 1. Copy 6 bytes from position 1 of the input frame to position 21 of the output frame. Line 2. Copy 6 bytes from position 34 of the input frame to position 1 of the output frame, etc. The ANI file also contains all the information required to initialize all EtherCAT slaves, including the safety IOs. There is also an application node. Link below the video. To test its configuration, an EtherCAT master is also integrated in Kendrion ENI Studio. This uses the copy instructions as described, and also the initialization that can be found in the ENI file. We start the EtherCAT master for a test and wait until initialization is complete. The Run LED lights up green, and we can now see the inputs for the 2-hand module in the input process image. If we switch both inputs, the selected output is set in the output process image. The bit offset describes the bit position in the frame at which the respective data is located. As the process image starts with a bit offset of 80, the actual position in the frame is the respective bit offset minus 80. Our first input therefore corresponds to 352 minus 80 divided by 8, which corresponds to the first bit in byte 34 of the process image. Our exchange variable, which represents the status of the 2-hand module, is also easy to find. Position is bit position minus 80, which corresponds to byte 13 in the frame. Its value changes when the 2 inputs are set. And with that, our brief excursion into practice has come to an end, and we have reached the end of this tutorial. Thank you for watching, and I hope I was able to show you how easy it is to use all of our safety modules and all of our safety functions by importing the ENI file into any EtherCAT master.